I fell down into the rabbit hole 2014 when I started to work at CloudAMQP, where we provide, now it doesn't work. I use this instead, where we provide RabbitMQ as a service. My goal when I started to work at CloudAMQP was that I wanted to make it more easy for everyone to get started with RabbitMQ. I wanted to bring simple use cases to the public and also point out all the benefits of using RabbitMQ. So I started to write technical documentations, update code examples, write blog posts, more blog posts, tutorials. I answered questions at Stack Overflow, and I also created 2 ebooks. So today, sometimes, when I'm at a bar having a beer or when I talk to unfamiliar people, I ironically call myself an influencer. And the life of a blogger and an influencer of this kind is almost as glamorous as you might think. You get spoiled with all kinds of luxury, and you get to hang out with important people. And I don't know if you can see it, but it's a dog trying to disturb me because I work from home a lot. I have, during my time at CloudAMQP, replied to more than 3,000 emails about RabbitMQ, and I have, as Johan just said, been part of the urgent support team, where we respond to urgent support issues, which could be when a client needs attention directly, when a server is running out of memory, or when RabbitMQ is under heavy load. With all this writing, many things were documented. I met up with different customers to see how they are using RabbitMQ. And I wrote down lots of common use cases. We collected anti-patterns, errors we see in setups, configuration mistakes, and all sorts of common mistakes that we see. Things that can go wrong and things that works out well. So what kind of issues are we dealing with then? First of all, we have client-side problems, where users like you and me or client libraries are using RabbitMQ in a bad way. And then we have situations where things are just not done in an optimal way. And then, of course, we have the server side, servers running old versions, misconfigured servers, or when the setup of the server is not configured for a selected use case. So I will today spread the knowledge and talk about what we have learned from running thousands of RabbitMQ nodes. But before we go into all the things I have already written down all over the internet, my name is Lovisa, and I'm from Umeå, Sweden. I do work at 84 Codes, which is the provider of CloudAMQP. I work as marketing manager and support engineer and lots in between. I have a growing family of lovely colleagues, and many of them are with me here today. And they are always happy to talk, so come by and talk to us in our booth downstairs. 84 Codes is also the provider of 3 other services: Cloud Kafka, which is Apache Kafka as a service, Elephant SQL, PostgreSQL as a service, and the hosted message broker for IoT, which is named the CloudAMQP. We work remote from all over the world, and we also have customers from all over the world, but we have our headquarters in Stockholm. We are today the largest provider of managed RabbitMQ servers with thousands of running instances in 7 clouds in 75 regions. And I will now give some recommendations where sum is equal to 16. And I will also give a summary of all these recommendations in the end of this presentation. And I know I will repeat lots of things that has already been said today, but I did not really have time to rewrite my slides. So recommendation number 1, try to keep a connection and channel count low. Each connection uses about 100 kilobytes of RAM, and of course even more if TLS is used. So thousands of connections could be a heavy burden on a RabbitMQ server. So especially if you're running on a small instance. And believe it or not, connection and channel leaks is one of the most common errors that we see. But luckily, it's mostly on staging and dev servers. Number 2, make sure you don't open and close connections or channels repeatedly. Doing that gives you a higher latency as more TCP packages has to be sent and received. And the handshake process of an AMQP connection is, as mentioned before, quite involved and requires at least 7 TCP packages, and again, even more if TLS is used. RabbitMQ is optimized for a long-lived connection. So keep connections if you are able to, and keep them open and reuse them if you are able to. Channels can be opened and closed more frequently, but even channels should try to be long-lived if possible. And best is to not open a channel every time you're publishing. Each process should ideally only create 1 TCP connection and use multiple channels in that connection for different threads. And we deal with servers that are under heavy load due to opening and closing of connections almost every week. Some clients can't keep long-lived connection to the server, and this has, as I said before, an impact of latency. One way to avoid connection churn is to use a proxy that pulls connections and channels for reuse. And we have developed an AMQP proxy for this. And our benchmarking showed that that proxy is increasing publishing speed with a magnitude or more. And there is a link to the GitHub repo in the slides. We are developing in many different languages. And this proxy is developed in Crystal, which we are also a really proud sponsor of. Number 3, one should always separate connections for publish and consume. First of all, imagine what will happen if you are using the same connection for publisher and consumer when the connection is in flow control. The flow control connection, a flow-controlled connection is a connection that is being blocked and unblocked several times per second in order to keep the rate of messages at a speed that the rest of the server can handle. A publisher and consumer on the same connection might worsen this flow control, since you might not be able to consume messages when the connection is being blocked. Secondly, RabbitMQ can apply back pressure on the TCP connection when the publisher is sending too many messages to the server. And if you consume on the same TCP connection, the server might not receive the message acknowledgement from the client. And so the consumer performance is affected too. And with lower consumer speed, the server might be overwhelmed after a while. I will start to speak Swedish. As I said, I'm Swedish, and if you know something about Sweden, except Swedish fika, then it might be that we love queuing. What we don't like is large queues, or when people in some way try to squeeze us in before you in the line. So recommendation number 4 comes straight from my heart. If it's your use case, try keeping your queue as short as possible. A message published to an empty queue will go straight out to the consumer as soon as the queue receives the message. And of course, a persistent message also will be written to disk. It's recommended to have less than 10,000 messages in a queue, and many messages in a queue can also put a heavy load on the RAM usage. And in order to free up RAM, RabbitMQ starts flushing or page out messages to disk, and this page out process usually takes time and blocks the queue from processing messages when there are many messages to page out. Another thing that is bad with large queues is that it's time-consuming to restart a cluster with many queues, since the index has to be rebuilt, and it's also time-consuming to sync messages between nodes in the cluster. Large queues is also a very, very common error that we have that our customers have. A queue is just piling up due to missing consumers, or due to that clients are publishing messages faster than the consumer is able to handle the messages. And then eventually, the server is overloaded and killed. And when this happens, we usually add up more power to those machines, but it still takes time to restart the cluster because of the rebuilding of the indexes, etc. It's sometimes recommended for applications that often get hit by spikes of messages and where throughput is more important than anything else, to set a max length on the queue, because this keeps the queue short by discarding messages from the from the head of the queue. Number 5, a feature called LASIK was added in RabbitMQ 3.6. And LASIK writes messages immediately to disk, and so spreading the work out over time instead of taking a risk of a performance hit somewhere down the road. Messages are only loaded into memory when they are needed, and thereby the RAM usage is minimized, but the throughput time will be longer with LASIK. So LASIK gives you a more predictable and smooth performance curve without any sudden drops, but at the cost of a little overhead. And if you're sending many messages at once, like if you're processing batch jobs, or if you think that your consumer will not keep up with the speed of the publisher all the time, then we recommend to enable LASIK. And we think that you can ignore LASIK if you require high performance, or if you know that your queue will always stay short due to max length policy or something like that. Number 6, the RabbitMQ management interface collects and calculates metrics for every queue, connection, and channel in the cluster. And setting RabbitMQ management statistic rate mode to detailed could have a serious performance impact and should not be used in production if you have thousands upon thousands of active queues or consumers. Recommendation number 7. Queues are single-threaded in RabbitMQ, and one queue can handle up to 50,000 messages a second. You will, I'm losing my voice. You will therefore get better performance if you split your queues over different cores and nodes, and if you route messages between multiple queues. And queues are bound to the node where they are first declared. So all messages routed to a specific queue will end up on the node where that queue resides. And you can, of course, manually split queues evenly between nodes, but the downside is that you need to remember where that queue is located. And we recommend 2 plugins that can help you if you have multiple nodes or a single node cluster with multiple cores. And it's the Consistent Hash Exchange plugin and RabbitMQ Sharding. The Consistent Exchange plugin has been mentioned a lot today. And the plugin allows you to use an exchange to load balance messages between queues. So messages sent to an exchange are consistently and equally distributed across many bounded queues. And it could quickly become hard to do this manually without adding too much information about number of queues and their bindings into the publishers. And note that it's important to consume from all queues bounded to the exchange when using this plugin. The Sharding plugin, RabbitMQ Sharding, does the partitioning of queues automatically for you. So once you have defined an exchange is sharded, the supporting queues are automatically created on every cluster node, and messages are sharded across them. And sharding shows one queue to the consumer, but it could be many queues running behind it in the background. And then we have priorities. Queues can have 0 or more priorities, and behind the scenes of a priority queue, a new backing queue is created. So each priority level uses an internal queue on the Erlang virtual machine, which takes up some resources. And using 255 or even thousands of priorities means you will have resource usage similar to having close to that many queues. And in most use cases, it's sufficient to have no more than 5 priority levels. This is fixed in RabbitMQ 3.7.6. The max priority cap for queues is now enforced and set to 255. And applications that rely on a higher number of priorities will break, and such application must be updated to use no more than 255 priorities. Because we had, like 2 weeks ago, or maybe 3 weeks ago, a case where 2 consumers were starting up RabbitMQ, and it took really long time, and memory usage just exploded, as you can see there. And this was despite few queues and few messages, which is the common error when it takes a long time to restart a broker. But this time it was due to many priority levels. Everyone needs to be prepared for broker restarts, broker hardware failure, or server crashes. And to ensure that messages and broker definitions survive restarts, we need to ensure that they are on disk. And messages, exchanges, and queues that are not durable and persistent are lost during a broker restart. So make sure that your queue is declared as durable and messages are sent with delivery mode persistent. And remember, persistent messages are heavier as they has to be written to disk. So for high performance, it's better to use transit messages and temporary or non-durable queues. And then we have the prefetch, which is used to specify how many messages that is sent to the consumer and cached by the RabbitMQ client library, how many messages the client can receive before acknowledging a message. And it's used to get as much out of the consumer as possible. And RabbitMQ default prefetch setting gives clients an unlimited buffer, meaning that RabbitMQ by default sends as many messages as it can to any consumer that looks ready to receive them or accept them. And messages that are sent or cached by the RabbitMQ client library in the consumer until it has been processed. So not setting a prefetch can lead to clients running out of memory and makes it impossible to scale out with more consumers. In RabbitMQ, we got RabbitMQ 3.7, we got a new option to adjust the default prefetch value, and this value is by default set to 1,000 on all new CloudAMQP servers with version 3.7 or higher. Or it doesn't really exist yet, but soon. A too small prefetch count may hurt performance since it's most of the time waiting for permissions to send more messages. And this figure is illustrating a long idling time. In the example, we have a prefetch setting of 1, and this means that RabbitMQ won't send out the next message until the round trip completes, where a round trip is deliver, process, and acknowledge. And we have in this image a total round trip time of 125 milliseconds with a processing time of only 5 milliseconds. So a too low value will keep the consumer idling a lot since they need to wait for messages to arrive. A large prefetch count, on the other hand, could deliver lots of messages to one single consumer and keep that consumer busy while other consumers are held in idling state. And in this image, we have one client that has a lot to do and one that is just waiting and has nothing to do. So if you have one single or few consumers and are processing message quickly, we recommend prefetching many messages at once and try to keep your client as busy as possible. And if you have about the same processing time all the time and the network behavior remains the same, you can use the total round trip time divided by processing time on the client for each message to get the estimated prefetch value for each message. And if you have many consumers and short processing time, we recommend the lower prefetch value than for a single or few consumer. And finally, if you have many consumers and or long processing time, we recommend setting prefetch count to 1 so that messages are evenly distributed among all your workers. And here's another thing that you should remember, it's that if your client auto-act messages, the prefetch value have no effect. Hype increases servers throughput at the cost of increased startup time. So when you enable Hype, RabbitMQ is compiled at startup, and this throughput increases with 20 to 80% according to benchmark tests. The drawback of Hype is that startup time increases quite a lot too, 1 to 3 minutes, and it's therefore not recommended if you require high availability due to this long startup time. We don't consider hype as experimental any longer. 6% of our clusters has hype enabled, and we haven't seen issues with hype for a really long time. Acknowledgements let the server and client know if the message has to be retransmitted again. And the client can either act the message when it receives it or when the client has completely processed the message. So pay attention to where in your consumer logic you're acknowledging messages. A consuming application that receives essential messages should not acknowledge messages until it has finished whatever it needs to do with them, so that unprocessed messages don't go missing in case of worker crashes, exceptions, etc. And the acknowledgement has a performance impact. So for the fastest possible throughput, manual acts should be disabled. Publish confirm is the same thing, but for publishing, and the server acts when it has received a message from the publisher. Publish confirm also has a performance impact, but however, one should keep in mind that it's required if the publisher needs messages to be processed at least once. Thanks to the RabbitMQ team, great improvements are made all the time, which is really great. In 3.7, we got the default prefetch, as I just mentioned, and this will probably completely remove cases where the consumer has been killed due to a too large message delivery due to an unlimited prefetch value. And individual vhost message stores are now available, and this helps us at CloudAMQP a lot, because we have 2 subscription plans that are shared plans, which gives a customer a single vhost on a multi-tenant server. And this means that our shared plans can be even more stable, and even if you have multiple vhosts on a dedicated plan, it will also be more stable. RabbitMQ 3.6 had a new feature, LASIK, that gave many of our customers a more predictable and stable cluster. And we found the LASIK feature so good that all our new clusters with RabbitMQ version 3.6 or larger has LASIK enabled by default. Many of our customers with issues are running old versions or documented unstable versions. And 3.6 had many memory problems up to version 3.6.14. And 3.5.7 was good, but lacks some good features like the LASIK feature. And we still have lots of servers running 3.5. And this image is a RabbitMQ version distribution between CloudAMQP customers. And it's nice to see that so many has upgraded to 3.7, because it's always something we try to push to, like we want our customers to run new stable versions. And we always test new versions before that we set them as available versions in CloudAMQP. So the menu that is selected in our drop-down menu on the page where you select which version you want to run, that is the version we recommend at the moment. So this recommendation is stay up to date with things that is happening in RabbitMQ and use a stable version, and also a stable Erlang version and a stable client library version. Some plugins might be super nice to have, but on the other hand, they might consume a lot of resources. Therefore, they are not recommended in production servers, so make sure to disable plugins that you are not using. An example of a plugin that we are using a lot, but that we are disabling every time we are finished using it is the top plugin, which we are using when we are troubleshooting RabbitMQ servers for our customers. Number 15, even unused queues takes up some resources. Queue index, management statistics, etc. And leaving temporary queues can eventually cause that RabbitMQ runs out of memory. So make sure that you don't leave unused queues left behind, and set temporary queues as auto-delete, exclusive, or auto-expire. Many of our customers are creating vhosts, custom vhosts, and then they forgot to add HI policy on the new vhost, and which causes message loss during net splits. And we have an HI policy on all our clusters, even single node clusters, because we're using that when customers are upgrading to new versions, or if they want to change from 2-node cluster to a 3-node cluster, we use that. And if they want to upgrade the RabbitMQ versions, etc. And here is a summary of it all. Try to have short queues, use long-lived connection, have limited use of priority queues, use multiple queues to consumers, and split your queues over different cores. Use a stable Erlang and RabbitMQ version, and also client library version. Disable plugins you're not using. Have channels on all your connections. And separate connections for publisher and consumer. Don't set management statistic rate mode to detailed in production. Delete unused queues, and set temporary queues as auto-delete. And for those of you who are interested in recommendations for high performance, then this is even more important with short queues, and use a max length if possible. Do not use lazy queues. Send transit messages. Disable manual acts and publish confirms. Avoid multiple nodes. Enable RabbitMQ hype. And for those who are more interested in high availability, enable lazy queues. Have 2 nodes, and don't forget to add the HI policy. Use persistent messages to durable queues, and do not enable hype. And the last one is due to this long startup time. We have created a diagnostic tool that is available from the CloudAMQP control panel, where customers can validate the setup, RabbitMQ setup, and get a score of this setup. And it's been used by many customers, and it's nice to have when we get a support request, we could check this one first, and then always get back to customer and say, you need to fix this, and this. And then the server is usually running much better after that. And here are examples of things that are validated in this diagnostic tool. And I think I've talked about many of them, but not all of them. And just come down and talk to us if you want to see it. As we have seen, best practice recommendations are different for different use cases, and some applications require high throughput, while other applications are publishing batch jobs that can be delayed for a while, and other applications just need to have lots of connections, and trade-offs have to be done between performance and guaranteed message delivery, etc. And our customers are today able to select number of nodes when they are creating a cluster, a single node for high performance, and 2 or 3 nodes mainly for high availability and/or consistency. We also have lots of other features built into the CloudAMQP control panel, like the option to configure alarms for queue lengths or for missing consumers, etc. And users can view how many messages there has been in the queue over time, which helps us a lot when we are troubleshooting our servers, since statistics for the queues are available all the time. And we also show metrics for usage, like CPU, RAM, and the disk. And we have seen many different use cases, and our future plan at CloudAMQP is to make it even easier for customers to quickly set up a cluster specified for a selected use case based on best practice recommendations. This is my final slide. And it would be nice if we could have a list like this in the community, like a list of recommendations, because it makes it so much easier for beginners to start using RabbitMQ. So if you have any recommendations of things that we need to add, or if you have different opinions about something, just let me know or send me an email or reach out to me. Thanks.
Perfect, thank you. Let's get started with some questions.
Yeah, I would say that too. It would be really nice if Anders, do you want to join me for questions? This is our lead developer, and he's also the one who should take a lot of credits for the diagnostic tool that we have.
Hi. Do you use which public cloud provider to serving the RabbitMQ, and how is the scale up and scale down in each cluster node using the Docker container or EC2 based virtual machine or another, and how which metric to using the scale down and scale up cluster nodes?
The customer can select a data center. That was the first question, right? They can select the data center when they create the cluster. They can choose between Amazon, Rackspace, IBM Cloud, Alibaba Cloud.
All of them.
All of them. And yeah.
And what was the other part of the question? How we bootstrap? We don't use any Docker. Yeah. No, we just
serve these cluster properties.
No, we just use like the cloud providers, different APIs to spin up instances, and we have all our bootstrapping in Bash scripts, so no fancy container stuff.
And which metric to using the scale up and scale down policy cluster nodes? Auto scaling.
Yeah, so basically the same as for bootstrapping. We use cloud providers APIs to spin up instances and bootstrap them with our custom scripts and add them to the Rabbit cluster and remove the smaller old nodes. So like rolling, adding new nodes, removing old ones.
Hi, one question. You're just doing everything with Bash scripts? Is there no technology like a BOSH or something like this behind of this, like Kubernetes or Docker or BOSH?
No, Bash.
Just Bash, okay.
Yes.
Thank you for the talk. That was awesome. I wonder if you have a strategy to help customers to keep up to date, like if you handle part of the upgrades, if you provide tools or anything else.
The customer we have in our control panel, we have a simple button where you press upgrade, and we send out information like now it's a new RabbitMQ version. It's good because of this, and this.
And whenever we can, we do that without downtime. So it's if it's a patch upgrade, we do it node by node. But if it requires downtime, then yeah, we notify you before.
But on the slide about high performance, you had a bird, and the slide about HA, you had like a mound. What is that mound?
I really don't know. Because it's many ants. Oh, it's an anthill. Yeah, it's an anthill. And the bird is flying high. That's the reason. It's not something I've been thinking about a lot.
So thank you for the talk. Would you say that RabbitMQ 3.7 is more stable than 3.6, 14, and later? Please be honest.
What was the question?
If RabbitMQ 3.7 is more stable than 3.6, I would say yes.
I would also say yes, I think.
The early versions of 3.6 we had a lot of problems with, but yeah, the current 3.6 version and all the 3.7 versions have been working really good.
And the LASIK use it was a really good feature for us.
Final questions? Yes, a final question.
What's the downside of using HIPI with HA?
Using hype. Okay.
The downside of using hype. It's. I wish I.
Mainly when a node has to come back online after net split or something, it can take quite some time to boot with hype enable.
And it takes really long time if there is already a lot of messages in the queue, and then if you add hype on that, it takes much longer time.
Okay, thank you very much, Lovisa.
Thank you.